Hello and welcome back to Compiler Programming. In the last video, we made good progress towards making our functions more robust. In particular, now you can define functions in reverse order and you can actually call one function from another as long as that call does not contain any arguments, which is something we will fix today, at least for one argument. And today I want to take this test that we have here, which is us just trying to call exit process from kernel 32, and I want to copy it and I want to create a second version, so test parsed. And this version, unlike this one, will not use JIT, but will use our parsing. So we'll take the code that we have here and try to figure out what that will look like and to have it in text rather than using macros. So first of all, we need to have a main function, and so that we can set this entry point over here. So we'll do something like this. Main will be a function that gets nothing and returns nothing, and that function will call exit process of as 0. Okay, that is nothing really fancy. Exit process is actually returning something, so I guess we should have it for now returning stuff as well, although it doesn't really matter. Right now we just don't have a way to ignore the result type, but maybe we will fix it as well. Let's see. Let me add a to-do here, saying to-do allow implicit conversion of last statement in function body to void. Okay, this is our main, and we also need to have actually let's continue trying to do it in reverse order. So we want to import exit process, and here's how I want to do imports. Import will be just a regular function definition like anything else, except that it will not have a body and have something else. So S64, and here would go a body, right? So here we would write this stuff, but here I want to do something else, and in particular I just want to say import, and we pass in what we needed. So first of all, I'll need to escape this stuff, and we say that this is gonna be kernel 32 DLL, and it will be exit process. I mean, it's also might be okay if we do like a more high-level thing where exit process will not have to be repeated twice, but I think that's okay for now because you also not always want to name your imported function exactly the same as the original one. Okay, so this is fine. This is also good. We look up main and we say that entry point is main. The only issue is this actually requires a builder, and instead we will have a value. So that's something that we will need to figure out. We either need to change how this stuff works or what we store in there. We'll see. For now, that's not really important. We will have a bunch of errors before that anyway. So that's just something to do. xme set as entry point. Okay. As is built, we have a redefinition of main. Yeah, that makes sense. Let's call it entry point. Entry. Oops. Like this. Great. Let's try to run the tests and see everything explode in spectacular way. Okay, let's start by one. And we have 688. This is the first assertion that we are getting, and the problem here is we are expecting the body to be a curly thing, while it is not really that. So what do we need to do instead? Well, we just need to say that we want to have something, but we don't really check if it is a curly brace. So this will allow us to continue a little bit further, and let's see where else we break. Okay, now the problem is on line 7 to 9, and in particular here. So we failed to reduce everything to 0, which is interesting. I wonder where it failed. Oh, I do know where it failed. So it failed over here because we basically matched these three things, but this is not what we were interested in. What we were interested in was the import followed by this stuff. And for now, I'll just hardcode import, but eventually import will be a macro or compile time function or whatever you want to call that thing. That is just going to be defined like everything else. But for now, that's going to be hard-coded over here. So we'll have exactly the same setup as we had for other stuff. So I can just basically copy these things and put it here and say that this is matching symbol imports. Okay, we are matching paren preceded by import. So I actually will do it together. So this is token name ID and source import. If not name, then continue. If not args, we also continue. This actually doesn't need a slice. Okay, so it's like this. Do we have import, we have args, and we need to do something about that. Well, first of all, we need to match import arguments as well. And there it is more or less the same setup. Okay, let's say that, what will this do? Well, as far as imports go, we we don't really need to make them lazy. I guess it would be nice in terms of us not importing stuff that we don't end up using in the program. But for now, I will not do that. At least laziness is not required for functionality like it was with ordering of regular functions. So for now, I'll just do that. I'll say value star token import match arguments, and I'm gonna pass in token star rn hero. Assert that rn type is token type rn, and I need to do the following. I need to say that assert that rn array length of paren is 3, and then I can get it like so. So I say token star library name is dynamic array get of parent children. It's supposed to be like this. Okay, 0. Maybe I actually will just use the same stuff. Yeah, let's do it like this. It's fine. We say root is parent, and then I can do these things. So this would be, yeah, we have a comma it's between them, and then actually just assert comma. We need to get the library name and the function name or symbol name. So library name string supposed to be a token type string. Okay. We are checking that, and we're also checking that we have another string, which is a symbol name. Okay. So we have this stuff. Now we need to turn string literals into actual usable strings, because for now I don't allow any escape sequences in the strings. I can just take the source and cut out the start and the end, and it will be what we wanted. So let's say that slice token string to slice or something. Token star token, and we assert that token source length is more than 2 or equal to 2. So at least there is a starting and ending quote. And then we say return slice bytes is token source bytes +1, and length is token source length -1. So this just moves pointer 1 byte over, and this reduces it from the other side. So that's like this. We now should have two strings. So we say slice library name is token string to slice of library name string. Yeah. And then we have the same for symbol. Okay. Symbol name string. Because it's supposed to be like that. Good. And once we have it, it means we can actually call C function import or not. So where is this C function import actually defined? Value C, I think it's here. So we'll have to do some more stuff. This extracts a name. This is really interesting. Yeah, so we want import symbol. Okay. This stuff actually should be changed. So in particular, there's going to be quite a refactoring, but I'm fine with that, I guess. We will do it as follows. It will accept now slice, which means that import library would also work with slices. So const char star, yeah, that's going to be slice and slice and slice and more slices. There's gonna be a lot of errors, like a lot. And so let's deal with them one by one. Slice equal case ASCII case insensitive. No, apparently I don't remember how it's spelled. ASCII case sensitive. Okay, so it's actually called, so this is, okay, it's like this. Slice ASCII case insensitive equal. And here it is just slice equal. Okay. I think this one I might even keep as it is, but yeah, let's keep this one for now as it was. Because we're not gonna call it from our parsing code anyway, so it doesn't really matter. Is from C string. Okay. Making some progress. Program find import. This was actually wrong. So it's good that sometimes it's good just to go and do the refactoring through the code, even if it's a dumb one, because you realize that you find issues. Like here, we should use case insensitive equal, and this thing actually also should be like this. Okay. Ooh, this is gonna be a bit of a nightmare. There is a syntax of printf to print. I think I have this. Do I have this? Print slice. Does that exist? Print, slice print. Okay. So let's do it like this then. It's not very efficient, but this is debugging code anyway, so who cares? Rip import. Then we have this, and then we have like this. Okay, it's fine. What do we have here? Okay, this is where we are actually needing to have a proper C string, because that's what we pass to the library, but it's perfectly fine to just create one. So we say const char star library name is slice to C string and lib name. Yeah, we need to pass allocator, so temp locator, and then we have library name. Okay, and then the same thing goes here, where we say we have a symbol name, and it's actually, it should be called symbol, and you get symbol here. Okay, that is getting better. What is happening here? Well, here it's very easy. If not slice equal, this actually should be using fix me. This should use a function from here. What was it called? It was called program find import. This is what it should be using. Okay. If slice equal, okay, that's fine. This is also okay. I think we'll eventually get to the part where we are encoding stuff, but for now that's good. Okay, what do we do here? Getting back to our original problem, and what should happen is this. So essentially we can get an operand, but we don't know the value. Actually, in this case, yeah, we definitely don't know the value at this particular point. So we either have to introduce like a new token type, which is just gonna have an operand, or we'll just have one without a descriptor. This is what I will do for now, but I'm not super happy with it, but it will allow us to move forward. So import, we need to get program star program. That looks good. And here will be big fat 0. Okay. Yeah, we don't need to wrap it in slices because it's already a slice. So that's just not required. Okay, and we return a result. But in particular, we don't even need the result. We want to have a token. And what will we do here? Well, it needs to be token value make of result. Well, we say that it's going to be parent and then result. Okay, let's see what is happening here. So name size is pretty easy. Now it's going to be just length. Okay. We shouldn't copy an extra byte here. Oh, let me think about this. So this should actually be like so. Yeah. So basically all of this +1 and stuff, it's all about this non-terminating byte. And since slices don't have it included in there, in them, or might not have it included, we need to account for it correctly. So this is basically exactly the same. If I haven't messed up my calculations. Okay, and symbol name bytes. Okay. And this is basically the same. We do dot length and dot length and like this. Okay, we are building. So what I will want to do now is to comment out this test for now. Actually, this also needs to go away. So should parse and write out. Actually, this should be 42. But this is not what we were testing, since there was a big refactoring of library name handled, and this touches executable writing. Definitely a good time to run the test and yeah, make sure that it works. Okay, encoding. Well, git diff encoding C. So what did I change? Stairs CMP not equal, so this is not slice equal. That seems correct. And here this stairs CMP equals 0. Oh yeah, okay. So this is the issue, I guess. Let's see if it is. And it is great. Okay, so at least the refactoring from raw strings to slices was successful. That means we can continue chipping away at the actual target of our stuff. And we need to say that token star. So how do I replace this? I need this stuff. Okay. And here it is going to be +3. Yeah, +2 actually. Or even more precisely, I can do array delete because it's just one thing of I +1. Just to remind, what this does is it will take this, it will match it, and then it will replace this whole thing with a custom temporary token that will encompass the resulting value. Okay, token star result token is token import match arguments of args and program. Okay, this looks fine. Let's try to run tests with the new test. Okay. Is it still the same one? Yes, it is. Okay, that's quite interesting. Let's try to figure out what is going on. As solution. Where is our test? This is the thing, and we can stop here. Let's go inside. This is where we are trying to match import. Import is not going to be anywhere close to the start. In reality, it is token number. That's not going to be for a while. I'm not even sure where. I don't want to count how many tokens, but it's definitely not. It's definitely quite a lot. So let's try to check if we are actually matching it at all. Okay, we are. So, okay, yeah, that is indeed a bug. So let's try again. Okay, that is much better. What is going on over here? Over here we have 631 and it is this stuff. So yeah, we actually have invalid thing here. We need to tell what is the name of this, even if we're not using, but I think that's actually better. Let's continue. Okay. Next thing, source line 554. And here is a token match expression. Yeah, so this is happening when we are doing token force value and then this thing, right? And here we are trying to token match expression of this. And here we need to do something else. In particular, we need to say that if body type is token type value, and body value descriptor. And I will do fix me. Figure out a better way to distinguish imports. Okay. Descriptor. Else. So else we expect it to be an expression, but if it is, we just say that body result is well, it's an interesting thing. So we have to somehow change the resulting type. Well, no, not really. Okay, so we say that body, and then body result descriptor is builder descriptor. Body value. Whoops. Okay, something like this. Let's see how we are doing now. Okay, we are getting further, and this is where we are in the territory of trying to write out stuff. So I think the problem here is in matching of call arguments, which we are not doing very well at this particular moment. Where is this stuff? It is inside of match expression, and it is this thing. Yeah. So we have token match call arguments, and I would expect this to explode over here. So why does it? Okay, let me check. Sorry, 264. Had a bit of a brain freeze for a second. Return. Yeah. That's not correct. So it is fine. If we have it, it should be like this. So we say the descriptor is this stuff. Yeah. Body value. Okay, let's try that again. Okay, now this is what I was actually expecting to happen. And this is that thing about us not knowing what the hell are we going to do with arguments. And for now, since we spent quite a lot of time trying to wire up imports, I will not get into parsing arguments correctly, but instead I will say that array value pointer result is this stuff, and then I will say that if it is 0, we just return result. If it is 1, we add, what do we do? Well, we probably force the token force value of dynamic array get of token children 0, and we pass in the scope. Else we assert not implemented. Something like that. Token star differs, yeah. So we say token star wait, this needs to be like this actually, and then I want to say value star result, not result, but value, and then dynamic array push of so nothing to do. Okay, we push in to result what we got. Much better. Let's try that. No matching overload found. Interesting. Well, we are making progress. That is happening on line 638. I will just go straight into debugger and try to run that thing. So we don't need that, we don't need that. No matching overload found. Great. So what are we trying to call? Yeah, that's gonna be a bit annoying to figure out. Token match expression. So I guess here we can try to figure out what are we trying to do. So target is target, and the what are the args here? Target, target, target. So okay, it is a function. Function argument data length. Okay, so we do have one argument. Can I see what is going on? Not really. Okay, copy value. No. Add watch. Yes, this is what I wanted. Items 0. Okay. So descriptor is integer size 4. That seems pretty reasonable to me. And this is what we are looking at, the target. Okay. What about args? Oh, length is really messed up for the args, and this is happening here. That's not good. Okay. So let's see what's going on over there. Match call arguments. Let's try to stop here. First of all, value is fine, except it's of the wrong size, which is definitely something that will cause a problem. So what is the result? Data. Okay, so this is actually fine. Is it still broken? No. Okay, so there was just the problem of us being already in a different stack frame, and I guess we overridden some memory. So this is actually fine. The reason it doesn't match what we want is because the types don't match. This is an interesting problem in parsing in general, in implementing languages. Let me explain what happens. So we have 42 here. And at the point where you are you create that value, you don't really know what should be the type of it. You don't know if it is an signed integer, unsigned integer. Is it I don't know. It might even be a float depending on the conventions of the language. So one of the things that could be done is what I did, is basically where it is I just say it is 64-bit integer, and this is what we are using. For now, to move on forward, I will just turn this into a 32-bit integer when it's parsed, and then we deal with it later. But this is going to be an interesting video all in itself, with what other strategies with dealing with this and what will be chosen here. For now though, what I will do is we have this value from S64 here, and I will just change it to do this. This is not great. Fix me. We should be able to size immediates correctly or automatically. Okay, let's see if that gets us closer to what we want. Okay, what is going on here? Line 264. I think right now we now have an issue that, yeah, this is actually supposed to be like this and like this and like this. So all of these things will start changing to be 32s. Actually, this one is fine. This is okay. And this one needs to be, actually this one also is fine. It is only the ones where we have immediates that are causing problems. Great, well, we were able to write out the executable, but let's see if we actually can run it. Build, test, parsed. Moment of truth. And we have an issue. So this is what's happening, I'm pretty sure, is we have all by one error somewhere. We are copying an extra quote, and this is not great. So let's recheck these routines that are doing this sizing. So what do they do? This is the library name, right? Get this stuff. Oh yeah. I know what's going on. I actually screwed up. Token string to slice. Yes, this is supposed to be -2. Okay, let's try that again. Still fine, and I don't think it worked. Yeah, that does not look like the right thing to do. So let's open up and see what is going on. At least it got past loading, which is great, but it obviously didn't get to the right thing. Ah, yeah, okay. Duh. I have a fix me that talks about entry point. Obviously, we cannot do anything when we don't set the entry point, and it actually should be checked that we have one. Let's do that. So entry point, builder entry point. So I just need to say assert program entry point. So now if I run the tests, yeah, we actually assert instead of writing out a executable that doesn't work. So that's good. Now it's time to actually fix it. So how do we figure out? Okay, we use the builder and then we compare the builder with the program entry point. What if we would do it differently? What if we said that program entry point is a value and we, because I think function builder has a value. Yeah, it's a pointer to the pointer, but it doesn't really matter. I think it's still valid. Let's check that. How do I check that? Well, I can go to any place where we are doing function stuff. So function, yeah, that seems good. So here, I just want to check that builder value is something reasonable. Actually, result. Yeah, so that seems, it does seem reasonable. Actually, no, if it is a pointer to pointer, it is only valid within the scope of the builder. So that's not gonna work. Well, let's do it like this. I think I should be able to make that happen. Function begin. Yeah. So that's okay. We say, I'm not even sure why we are storing result. Where is the result used? Oh, actually, no, it does seem to be valid. So that's fine. So that means we can do that. So we go to validate age, and in program, in entry point, we just say that, you know what, entry point is now a value. So it's gonna be like this. And here we say builder star builder result is this stuff. Let's see if it works. Let's try to run test. Okay, well, we are, actually I don't know if it works because we didn't get to write things, but now I can say program entry point is entry. And we don't need to do this assertion because it will be done for us inside of the encoder. Let's see. Great, so we can try to run this stuff. And judging by the speed, it actually worked. Yep, here we go. So this is pretty nice. Obviously, there is a bunch of stuff to fix now. There is this void conversion. There is the whole topic about 64-bit, 32-bit, or what is the size of the immediate. So that's something that is not even going to be handled in parsing, I think, but rather I will try to handle it more generally. So we always store immediates as 64s, and then we decide how to deal with them. We might even decide to store them as big decimal at some point or something like this. So that's one thing. But overall, it is pretty good progress. Now we can import stuff from the outer world, and this paves the way for all the future stuff. That will be all for today. Thank you very much for watching, and hopefully see you next time.